conjugate root theorem again is now we're looking at the imaginary zeros. We already figured out how to determine how many possible positive and negative real zeros we have from Descartes' theorem. Conjugate root theorem is going to talk about our imaginary ones. Yes. These are examples that you can write kind of like in a column right along your paper. No, you don't need no space. You can do one each one. This is a one. So conjugate root theorem says that if the imaginary number a plus bi is a root of a polynomial equation with rational coefficients, then the conjugate a minus bi is also a root. First, let's review. What's another word for root? It's a zero. What's another word for root or zero? It's another word. X-intercepts. So root, x-intercept, zeros, they all mean the same thing. Where the graph crosses the x-axis. So, if you have an imaginary number, imaginary numbers are always in the form of a plus bi. A is your real part, b is your imaginary part, the bi is your imaginary part. So if that's a root of a polynomial equation, then its conjugate, which is a minus bi, is also a root. Okay? If you notice, the imaginary part changes signs. One's a positive, one's a negative, but the real part always stays whatever it is. Yes?
Is that because we already have imaginary numbers?
Exactly. When you do imaginary numbers, like think about it, if you have x squared equals negative 4, I think this is from your homework, right? When you took the square root, it was x equals plus or minus what? 2i. So you have a positive 2i and you have a negative 2i. Complex numbers, sorry, not complex, imaginary numbers always come in pairs. One's a positive, one's a negative. So just to practice to make sure that we understand that, if you have a polynomial, the polynomial's roots are given to you, like they are here. And these were your two roots. You have negative 4i and 2. Then you also know there's one more root. Yeah. So like I'll say it again, if you have negative 4i and 2 as two roots, then you know there's one more root. What root is not listed, but it is there? A positive 4i. Because remember, this is a common. If you have an imaginary number, its conjugate is also a root. So if we have a negative 4i, then we also have a positive 4i. Let's look at number 2. We have 4 minus 2i, 4, and 8i. These are all roots that were given to us. Now, if we're given 4 minus 2i, then we also know what else is a root. 4 plus 2i. It's the opposite. The imaginary part is always the opposite. It's conjugate. And we also know what else? We have negative 8i. Your real numbers, your real roots, they don't get duplicated, they don't change, they just stay where they are. It's only your imaginary ones that have the conjugate as well as a root. Let's look at number 3. I want you to write down 3 and 4. I want you to write down 3 and 4. What you think are the other roots that are also for these two polynomial functions? For number 3, what's the other ones? 1 plus 3i and negative 2i. Both of them were imaginary, so its conjugates were also roots. What about number 4? Negative I. Now please make sure that you distinguish your i's, okay? I don't want to have to be questioning whether that's a 1, that's a random point, okay? Please try to make it look like an I, okay? Let's make it try to look like an I. Now, to loop it a little bit, if this has 3 zeros, real or imaginary, this is a polynomial with a degree of what? 3. 3 zeros, doesn't matter if they're real or imaginary, this is going to be a polynomial that has a degree of 3. Its largest exponent is going to be 3. What about number 2? Thought I heard it. 5. Because you have 1, 2, 3, 4, and 5. No, that's not bad. What about number 3? 4. And then number 4? 4. Okay, so a polynomial, a 4th degree polynomial, or a 3rd degree polynomial, or a 5th degree polynomial. Okay? Now, the reason why I harp on that is because now we're going to write these polynomials. Okay? You're going to be given the roots, you're gonna write the polynomial equation. And come Friday, we're gonna go the other way. We're gonna get the polynomial equation, and then we're gonna find the roots. Okay?
So right now we're kind of working back.
Right now, we are working backwards. Yes. No, we don't multiply them all together necessarily.
Do we write this down in here?
Yes, this is inside the folder. This one's inside the folder. We're gonna do 4 examples. 4 examples. So, the first one, you're given these roots 3 and 1 plus I. Hold on, wait, I lost myself a little bit. Hold on. Nope, it's this one. Sorry. One more that's gonna go on your paper. One more that's gonna go on your paper. We're gonna do this one together, and then actually we're gonna do we'll do this on your own. So we are given 3 and 1 plus I. We're gonna write a 3rd degree polynomial equation. 3rd degree is also known as a cube. Okay. So let's make sure we have all of our roots. We have 3. We have 1 plus I, but we also have 1 minus I. Okay? I always like to start out with writing out all my roots. Okay? Any ones that might be hidden, I like to write them out. Okay? So that's where the 3rd degree is coming from, because we have 3 roots, so that means we're going to have, almost 3 zeros. Now, if you think back, whenever you were solving an equation, the step before you actually got to the x equals part, wasn't it always in a factored form? Okay? In order for me to get x equals 3, that had to come from a factor that was what? X minus 3. Because when you said x minus 3 equals 0, add 3 to both sides, you get x equals 3. So we have that factor there. Okay? And it works the same way with the imaginary ones too. Okay? Whenever you're given a root, you always want to write the factor form. And the factor form is always x minus whatever the root is. Every time. Every time it's Anderson? Yes, every time. What if the root's a -2? Well, you still write x minus, you just write the root in. The 2 negatives make a what? Positive. Okay? It's always x minus the root. Every time. Every time, every time. Question?
No. So you don't do x squared because you do both separate, right?
Yes. Now, with your complex ones, I am going to be just a little bit more careful because I don't want to lose any signs. I'm going to put 1 plus I in parentheses. And I'm going to do the same thing with the other imaginary number, x minus the root. So from here, it's a little bit of algebra. We're going to FOIL. Now, because we're dealing with some imaginary roots, always deal with imaginary roots first before you deal with the real ones. So what I'm going to do is I'm going to multiply this x minus 1 plus I and this x minus 1 minus I. Okay? So I'm just going to apply a little bit of math. I'm going to do line by line. Y'all let me know if you get confused anywhere. Okay? If I'm going to have no space, I'm going to make myself have no space. You guys do the same. Okay? Here we go. What I'm going to do first, I'm going to distribute this negative to this root. So I'm going to have x minus 1 minus I and x minus 1 plus I. And the only reason why I'm doing that is I'm trying to get rid of those parentheses within the parentheses. Is everybody okay with me up to here? I just distribute the negative.
Oh, okay.
Is everybody good? Now I just multiply. I'm going to multiply every single term in this the first parenthesis by every single term in the second parenthesis. So what's x times x? X squared. What's x times a -1? What's x times an I? Ix. Or xi. Either or. Now I'm going to do the second term. What's -1 times x? Negative x.
When we do this, we put like terms underneath each other.
Yes. You definitely do this. Put like terms on each term. Yes. What's -1 times -1? Positive 1. You can also do the box method if you're a box person. What's negative 1 times I? Last term. Almost there. What's negative I times x? Negative ix. What's negative I times a negative 1? I. And what's negative I times an I? It's negative I squared. Now I'm going to write this just for this purpose here. I squared. Think back to algebra 2. That's a negative 1. So I squared turns into a negative 1. So a minus I squared would be a what? Positive 1. So keep that in mind. Now if you look, don't I have some other like terms? Negative I and positive I cancel out. Negative ix and positive ix cancel out. And if you FOIL correctly, all of your imaginary stuff should go away. Every single time, if you do it correctly. And I squared is always going to be negative 1, so that's gone. And all of your other like imaginary parts cancel out. So now I'm just left with an x squared minus 2x, careful. And then 1 minus a minus 1, which is just so now you're just dealing with real numbers now, no imaginary stuff. Now the last thing you have to do to get the final polynomial equation is multiply x minus 3 to x squared minus 2x plus 2. The distributed table. Go ahead and do that. Go ahead and multiply these two together. So once you multiply, you have to combine like terms to get x to the third minus 5x squared plus 8x minus 6. Did you guys get that? And that is your polynomial with a third degree. Questions? All right, look at the foldable. Here we go. Here's the first one. You're going to write a blank polynomial with rational coefficients with roots 5 and a negative 3 plus 2i. I don't tell you what type of polynomial it is. You yourself have to tell me what type of polynomial it's going to be. Look at those roots. You do have to write in the roots. 5 and negative 3 plus 2i is not in there. What are my roots? 5 and negative 3 minus 2i. So this is going to be what type of polynomial? What degree? Yes, this is a third degree polynomial, also known as a tricubic polynomial. Trinomial already takes care of the term part.
Were you supposed to go on how many roots there are? That's how you figure out which ones are the
Exactly. That's why I always like to list them out so that way we kind of already know what to look for. Since we got 3 roots there, we should have when we do the multiplication, it should be whatever x to the third.
And now you want to figure this out?
Yep. So I'm gonna make sure we're okay before we get to the multiplying part. So let's write out the factors. It's gonna be
X minus 5.
x minus 5,
X minus 2. Negative 3.
very good. And the last one,
X minus 1.
now we multiply. Remember, you start with your imaginary part first, and then go to your real part. And if you do it right, all your imaginary stuff should cancel out. So I want everyone to do that right now, okay? Right now. Take your time on this. What do you get when you actually multiply the imaginary part out?
X squared plus 3x.
No, I mean,
X plus 3 minus 2i.
no, like the final thing, like here,
X plus 6x.
6x plus 13.
Oh,
You did not get this.
No.
And that meant that you messed up somewhere back here when you were multiplying. But you see how like one sign messed you up? Then you multiply this out. So then you get x to the third, final answer.
Plus 2x.
That's your final answer once you actually multiply the x minus 5 through.
The x squared. Wait, is that?
Yeah.
What group it's in?
Because you said 2 first, and I was like, oh no. There we go. Alright, here's the next one. Try this one. What does double root mean? We talked about this.
means there's two.
That means there's 2 of them. No, it's
It's a negative one, negative one.
It's a negative one and a negative one. Basically, a multiplicity of 2. Use a double root. So you basically have negative 1, not once, but twice. So your roots are 6, negative 1, negative 1, and 2. Making this a what degree?
Four.
A 4th degree polynomial. Now, 4th degree is all known as quartics. Double vocab at the same time we're going over lesson. What are the factors? X minus 6.
Wait, there's no op.
It's going to be x. There is no I. So we only got to worry about no imaginary, so we're just doing real ones right now. But it's the double root part that I wanted to make sure I go over. What's this factor? X minus the negative 1, which turns into a plus 1. X plus 1 again, and then x minus 2. Go ahead and multiply this out. Alright, so when you multiply this out, I don't know how you did it. I'd like to multiply the first 2, then the last 2, and then just multiply those together. But your final answer should have been x to the 4th.
Minus 6x.
Minus
Cube
5.
minus 3x minus 3x squared plus 16x plus 12.
So it might be more than one term.
I probably combined like 2.
Yeah, just be careful when you, like I'm telling you, all you have to do is lose a sign that changes your whole answer.
This unit is so, like, this doesn't have to take like 2 days.
I got like just the 5th one.
You're not
Okay.
gonna- Are you?
Q. That's 13x squared.
That's exactly what it's doing.
Yeah.
Well, listen.
One more to end it off. One more to end it off. Okay? This one you write it on your own. What's your missing root?
Negative 4.
So this is a cubic. It should end up with 1 to the third power. Keep working.
I got activity plus 3x squared plus 16x plus
Really?
We're naughty. Oh, reading that. Naughty is example.
No. Hopefully I don't make
I
that
did.
Just trying out terribly.
I didn't get that.
So she sees me playing like trash, right?
Teachers, just as a reminder for the boys soccer, there are tryouts this afternoon at the Hunt Brothers Field. Today, Thursday, and
Did you guys get this one?
Yeah.
Okay, remember, always do the imaginary part first. Alright? We'll do the last one for your problem of the day. It's a doozy. Okay? But look this into your